Hey guys, welcome to our channel. So we've been decoding Mamwich, changing to Manwich. Um, we got our residue as evidence for the change. We got our extractions, got those to run through all the categories. We found the University of New Mexico as our potential quantum network suspect. And then we converted our extractions into numerology numbers using a numerology chart. Ran that through the categories. Then we connected the University of New Mexico to Manwich through gematria, and then connected that to the other 14 for a total of 15 effects we've connected so far through gematria. Then we converted our extractions into simple binary and ran that through the categories, and now we are on the alphabetic order. So we got that to run through stock market, finance, genetics, medical, chemical, atomic numbers, artificial intelligence, robotics, machinery, and military, laboratories, and research groups. And now we're on technology. So you got MN as our extractions. The only thing that happened was an M change to an N in Manwich. And we used this chart to convert M to 13 and N to 14. And that gives you 1314. All right. Now I found this interesting. If we start with 13, how about 13 technology trends that are Rule 2021? And I'm not going to get into most of them, but there's one in particular I want to get into. So you got 5G for enhanced connectivity. I think we all pretty much know about 5G. I shouldn't have to get into that. But here's this one. How about the rise of quantum computing? Quantum computing makes use of something called a quantum computer, which is vastly different from the computers used today. Unlike our personal computers, which we use for a range of things such as watching videos, browsing the internet, and working on documents, quantum computers are built to perform insanely powerful calculations that modern computers simply can't. Want to know why they're called quantum computers? Well, modern computers work on binary bits of data called 0 and 1, but these computers depend on quantum phenomenon like quantum superposition and quantum entanglement, and work on qubits. Today, these computers are being used to solve complex computational problems for domains like. This is where it gets interesting. Science and medications for detecting disease and saving diseases. And think of how many medications we get. Think of how much medical stuff we get. Think of the genetic stuff we get. And the technology. Science and medications for detecting diseases and saving lives. Finance for predicting markets, risks, frauds, and optimizing portfolio. We have a finance category. We have a stock market category. All right. So there's several of our categories. Manufacturing for optimizing the design of vehicles, batteries, chips, etc. So there's your machinery that Steve requested. And there's technology, both in one. Optimizing machine learning methods. Think of all the artificial intelligence and machine learning we find in here, along with many other domains like logistics, energy, etc. So maybe we should make an energy category. Maybe we should make a logistics category. They're telling us. Being extremely powerful, these quantum computers can achieve in hours what our best in-class computers today can do in months or even years. But as we know, as we learn if anyone watched the Geordie Rose video, these computers simply can't solve those problems. So here they're saying that it would take months or years. Geordie Rose says that these simply can't solve the problems. I would believe Geordie Rose first. But I find that interesting, guys. There's a bunch of our categories that says right here, quantum computers used to solve complex computational problems for these domains. So, anyway, you got driver monitoring systems. Also, are among the fresh new trends in technology that could play a pivotal role in preventing, or at the very least sharply reducing, the number of road accidents. I'm not sure what I think about this. The newer systems will use artificial intelligence powered software paired with cameras and various sensors to get a better idea of what's happening inside the vehicle. It will allow the vehicle to alert drivers when they're feeling sleepy or being distracted from driving. Not sure how I feel about that, but customer data platforms. As customers, we often provide bits of information to businesses every time we visit their store or online portal. This data could include our name, contact information, address, product preferences, previous transactions, product reactions, feedback, and more. So they use this. Customer data platform enables businesses to unify their customers' data in one place, which can be later fed into other systems or departments. This allows the business to understand a customer better and send tailored promotional material to them. All right. I don't think we're going to get any further into that. Distributed cloud technology. Cloud computing has become one of the hottest trends in recent years thanks to its increasing popularity. Various service providers now provide public cloud services to organizations. So these public clouds can be pre-configured with whatever the organizations may require, such as VMs, applications, development environments, and such. So cloud computing, intelligent apps, artificial intelligence, machine learning, data analytics, and other various components are playing a crucial role in giving our daily lives a mighty upgrade with intelligent apps. Although they may look like any other app, the real difference is underneath the UL. Their intelligence comes from underlying integration and use of artificial intelligence. And its numerous offerings with these technologies, apps can now use user data to analyze and predict their behavior and offer valuable predictions, insights, and tailored decisions when needed. So, intelligent apps. Blockchains and distribution ledgers. Blockchain is an enormous list of records called blocks that keep growing with each new transaction. And all these transactions are linked together using cryptographic methods called a hash, hence the chain in the name. So I don't think we need to go any further into that. We'll try to get through this. Edge computing. The idea behind edge computing is to bring the resources and the computation as close to the host system as possible to offer instant results. Curious to know how that happens? In edge computing, the host system or the edge server is built to perform most of the data processing tasks locally without bouncing the data back and forth from a server for any processing, although it most definitely can when needed. Key reasons for using edge computing could be close to zero network delay, reduction in bandwidth usage, um, savings in server and bandwidth cost, reduction in the server workload as fewer tasks are sent to the server for processing. Sensitive data can be processed locally without sending it over to other computers. So we'll move on. Artificial intelligence and machine learning. I think we've gone over that enough to know what that's all about. Augmented reality and virtual reality. I think pretty much everybody knows what that is. Intelligent Internet of Things. I think we've all heard about that before. Cybersecurity mesh. And more autonomous things, robots, drones, autonomous vehicles. So I think the most interesting thing there was the quantum computing. So now we're going to move on to 131, Montana Code Annotated 2021, 172131 right there, genetic engineering, technology, research, and development. And it says account created. But this deals with the Montana Code. Treasury funds and accounts. Genetic engineering and technology research and development account. So we'll move on from that and go to 3.1. And 31 is 31 CFR 542.306, information and communications technology. So this is legal information. And I don't think we need to get into that. Oh, man. Okay. If we move on from that, you have 314 IT services in St. Louis. And this is part of a phone number. And there's your 314 right there. So, no, I don't want to talk to the support agent. If we move on from that, you got 1314, the whole thing coming forward. And there's your 1314 right here, Journal of Chemical Technology and Metallurgy. So, yes, Journal of Chemical Technology and Metallurgy, whatever that is. He's got chemical engineering here, inorganic chemistry, chemical engineering, industrial automation, information technology, biotechnology, economics, and management. This is all, bring that up, right? This is all right here. So it deals with all this stuff. And that gets you through going forward. And now we'll come back. Start with 4.1. And where's my 4.1? Right here. It's a P41 grant. And it's National Centers for Biomedical Imaging and Bioengineering. The P41 grant mechanism. So these centers create critical and unique technology and methods at the forefront of their respective fields and apply them to a broad range of basic translational and clinical research. So we are coming back, and the next thing coming back is 413. And here's 413 right here, ISO/IEC 14776-413 2007. Information technology, small computer system interface, part 413, architectural model. So you got more information technology here. All right, we move on from that. No, that's where we're at. If we move on from that, is that where we're at? That's where we're at. Okay, if we move on from that, you got the whole thing coming back, 4131. And this is cell signaling technology. Whoop. Oh, cell signaling technology over here. Number 4131, phosphocystin B1 SCR147 antibody. And it tells about the limited uses of this here. But I think cell signaling technology is the thing to take from that. And that gets you through going forwards and backwards in technology. So we will do random next. And then we will combine some of these letters and numbers. And I'll figure out how to do that. And we will just see what we'll give that a test run and see what's there since we're here. And because these calculations, these conversions go on forever. And you end up with something like this if you mash it all together. This is Manwich, just from the MN. You end up with all that, letters and numbers, but we're not going to do that many. But we'll pick a spot to stop, and I will randomly combine these letters and numbers, and we'll see what's there. So, whoops. So that's going to be it for this one. So for now, guys, thanks for all your thumbs up, thumbs down when appropriate. Thanks for all your comments, leads, feedback, and subscriptions. And thanks for watching, guys. And for now, you guys have a great rest of your day.